First definition that we're going to work with is something called a linear combination. And I actually want to make this explicit. I'm going to say this is a note. Okay. What's one of the most famous formulas for a line in calculus? Yeah, y equals mx plus b, that works. Y equals mx plus b. And I'm going to do something crazy, okay? I want us to think about the m as a scalar and the x as a vector. And this is going to come in lesson 2019, I think, something like that, when we start talking about vector spaces. This is actually a vector in an infinite dimensional space, which is called the space of polynomials, right? I guess you could also call it the space of continuous functions. And then the same thing is true. Could you guess what function that is? It's the identity function. It's the function f of x equals 1 for all x values, right? Let me ask you this. If we're allowed to call this thing a vector and this thing a vector, what are these two operations right there? Scalar vector multiplication. And then what about this one right there? Vector vector addition. Many of you did this thing. This was not only this class, but also my other class, where you actually did vector scalar addition. We have no such operation in linear algebra. It happens that you can think about a vector and a scalar as matrix vector multiplication, but I don't want to worry about that right now. If you do scalar vector multiplication, what must be on the left-hand side? Scalar. What must be on the right-hand side? Vector. There's no such operation in our world where you have a vector on the left-hand side and a scalar on the right-hand side, and you're allowed to call that scalar vector multiplication. Just doesn't exist, right? I'm going to be pretty serious about that. So here we go. Whole idea of a line, if we do this, what is a line made out of? Scalar vector multiplication and what? Vector vector addition. And let me show you some non-linear operations. So that's what we call linear. This is what we call a linear thing. Let's do non-linear. Okay, so if I said that y was equal to x squared, so remember, everywhere we see an x, are we thinking about that as a scalar or a vector? We will get to the place where we think about those as vectors, which means, what type of operation is this? Yeah, no, actually it's not. Yeah. Well, later it will be called the inner product, but right now it's a multiplication between vectors. Yeah. Which means, does this fit into the linear regime? What's the only thing that linear means? Scalar vector multiplication and vector vector addition. So everywhere you see linear in this particular class, I want you to think linear means a very, very special thing. What does linear mean? Either scalar vector multiplication inclusive or vector vector addition.